So diving into a couple problems, notice the form right now. We have it in standard form, quadratic on the top and the bottom. But if you look at the examples I gave before, it really helps to expose these three things if you can get them into factored form. So let's go ahead and change this into factored form. So our top one will be what multiplies the 4 and adds a negative 4 would be negative 2 and negative 2. So on the top we'll have x minus 2, x minus 2. And then on the bottom, we will have what multiplies to negative 2 and adds a negative 1. Looks really bad diamond method there. Okay, and then that would be negative 2 and positive 1. So we'll put x minus 2 and x plus 1. There we go. So looking at this, where would you have a removable at? So you're going to have a removable at x equals 2. And I'm glad this problem came up. So 0, and then removable, and then vertical asymptote, I'll put VA. So removable at x equals 2, because notice right here, the x minus 2, we have it on the top and the bottom. So the removable is going to override the 0 on the top, by the way. So you notice that there's two factors, both the same on the top. That's why I'm glad this came up. Because it's a removable there, you can picture it at x minus 2. The graph is going to be going along at when x is 2, and it's removed there. So actually there's not going to be a 0 there. So the removable is going to outweigh the 0, only because the 0 would be the same. It seems like there's a 0 at 2, but because there's also a removable at 2, that's why we're going to go ahead and exclude it. So I'm going to put none on that one. And then for vertical asymptote, 0 on the bottom would be negative 1. There's no, that doesn't cause any issues at the top, doesn't cancel the top. So that would be at x equals negative 1. Let's look at another example. So for this one, let's go ahead and factor the top. So what multiplies a negative 81 and adds to 0 would be negative 9 and 9. This is a perfect, or difference of two squares, which we went over quite a bit in the past. And then for the bottom one, we'll have x plus 9. Actually doesn't need any factoring, so it'll just be x plus 9. And so for our 0, this time we'll have one. So x minus 9 doesn't cancel with anything on the bottom, but there is a 0. So 0 at x equals 9. If you plug in a 9, 9 minus 9 is 0, but it's not going to cancel at the bottom. There's not another factor of x minus 9. And then for removable, at x equals negative 9. Why x equals negative 9? Notice they're both in the top and the bottom. That would cause a 0 with both the top and the bottom. And then last, there's nothing on the bottom but cause a vertical asymptote. For that, I'm going to put none.